Hi guys, Marvin here from shopsadapage.com, and today I'm finally giving you guys my full review of the Bykski 240mm AIO. We're going to test this in various conditions and see how it performs in both stress tests and real-world performance. I'm also going to introduce to you in this video my methodology for testing AIOs so that you can get a better understanding of how I came up with my results. With that said, let's get into it. Alright guys, I already did an unboxing and first impression of this AIO, which you can check out here. I suggest you watch that first so that you can have an idea about my thoughts prior to actually testing this AIO in this full review. But basically, the Bykski AIO features addressable RGB pump and case fans that are compatible with ASUS Aura Sync, MSI Mystic Light, and Astrax Polychrome Sync. Now, it wasn't mentioned on the box, but it is also compatible with Aorus RGB Fusion, which I was able to confirm since I am now using an Aorus motherboard. The pump itself is rated up to 2300 RPM give or take, and the two case fans are rated up to 1500 RPM, which is a bit lower than I would like, but we'll see later how it will actually perform. I'll pop the complete specifications on the screen so that you can check it out. Essentially, what you're getting inside the box is a set of mounting brackets and screws for both Intel and AMD, a thermal compound, a rather small but easy to understand user manual, two addressable RGB case fans, an RGB controller powered by Molex, and a fan splitter. The design of the case fans is quite simple, black housing with white translucent for the fan blades. It is rated with 12 volts and 0.2 ampere. This is actually a vital information in case you're going to daisy chain your fans into a single fan header. It has anti-vibration rubber on all four corners on both sides, and it also has two connectors, a 4-pin fan connector and a 3-pin ARGB connector split into two with one female and one male connector. Now let's take a closer look at the Bykski AIO, and what we have here is the 240mm version. In terms of design and construction, it is pretty decent but nothing to write home about. The majority of the pump is made of hard plastic materials with copper-based plate, and it has this sort of two types of finish. The tubes connected to the pump is rotatable, but the Teflon tube itself are rather thin than I would prefer. But what I like with this the most is the design of the front of the pump itself. It has this honeycomb design with translucent lining and a small Bykski logo at the center. In terms of the radiator, it has a dimension of 274mm by 119mm by 27mm, which I think is pretty standard for a 240mm AIO. On its side, we have a Bykski logo right here. In terms of the interface, the pump has a fan connector and a 3-pin addressable RGB connector. Alright guys, before we move on to our benchmarks, let's check out the different lighting effects of this AIO. The Bykski AIO comes with an inline remote with clicky buttons where you can toggle all the different lighting effects. The only downside is it's not wireless like other infrared remote control. However, I discovered that the pump and case fans are actually compatible with ID Cooling's remote, so you can essentially connect all of them and change the lighting effects using just the IR remote of ID Cooling. With that said, here are all the lighting effects using the inline control from Bykski. The pump's RGB is synchronized with the case fans, so you basically have the same lighting effects. As you can see, the pump is certainly an eye candy, and the RGB illumination really pops out with the circular lining and the honeycomb design. I think this is one of the strong points of this AIO in case you're looking for an aesthetically pleasing one. Now, mounting the AIO is pretty easy. The instruction on the manual is easy to understand, but I feel like Bykski can improve the materials used for mounting the pump, especially the plastic part as you can see here. Alright guys, let's move on to our benchmarks, which is the most important part of this review. First, let me introduce to you my methodology moving forward for any AIO testing, because I think this is very important so that you'll get a better understanding of how I came up with my results. I'm not sure if I will mention this on all future AIO reviews, but this video should serve as the guide unless I change anything if necessary. Let's start with the specifications of my system. I'm currently using an AMD Ryzen 5 2600X processor in an Aorus B450 Pro Wi-Fi motherboard with 16GB of 3200MHz G-Skill Trident Z RAM, and I'm pushing pixels using a Zotac 1070 mini graphics card, booting from a 480GB Kingston UV500 SATA SSD. I have 6 ID cooling DF12025 case fans cooling the system inside a ROG Hawani Flow mid-tower case. I prefer to test AIO in a closed case because realistically, that's how I'm going to use it on a daily basis. Alright, so first I made sure that the BIOS of my motherboard is up to date. In this case, I've updated my Aorus B450 Pro Wi-Fi to BIOS version F50. I also made sure that Core Performance Boost and Precision Boost Overdrive is enabled to get the ideal performance out of my AMD Ryzen 5 2600X, making sure it is auto boosting up to 4.2 GHz. All the other settings including voltages are set to auto, but I'll show you guys later the actual values it achieves during an entire run, as well as the actual RPM of the pump and actual frequencies of the processor so that we'll leave no information behind. Now, the thing is, testing AIO is quite complicated compared to testing air coolers because with AIOs, it takes a lot of time for the temperature to level out due to the nature of its components. Liquid takes time to heat up and you also have to consider the surface area of the radiator and the tubes of the entire loop. With that said, I did a few different runs so that we can have an idea of how the Bykski AIO performs. I did a 15-minute idle test, a 1-hour AIDA64 extreme stress test which I think is long enough to capture accurate data when the temperature finally leveled out. I also did a 15-minute AIDA64 extreme stress test with all the fans and pump running at maximum speed to get the raw performance of the AIO. I also did a 30-minute Csgo Gaming test to get a real-world performance result. Like I said, I also captured the actual pump speed, CPU voltage, and frequencies during the entire 1-hour run so that we can make sure that the testing was as accurate as possible. And for good measure, I also did another run of everything using a Noctua NTH1 thermal compound. With that said, I think I did my best to capture data as accurate as possible, and I also tried my best to maintain an ambient temperature of around 29.0 to 29.7 degrees Celsius. Again, this would be my methodology moving forward for reviewing AIOs, and I think this is also a more accurate test compared to when I initially reviewed the ID Cooling FrostFlow X AIO. Alright guys, I think I'm done explaining things, so let's head into our benchmarks. So in a 15-minute idle test, the Bykski AIO's average temperature is 41.5 degrees, which I think is pretty decent. After that, I ran a 1-hour AIDA64 extreme stress test, and the Bykski AIO's average temperature during the entire run is 54.2 degrees. This is with auto-calibrated standard fan curve using our Smart Fan 5 software. Now, to eliminate any possible inaccuracy or issue due to fan curves, I also did a 15-minute AIDA64 extreme stress test with all the case fans including the pump set at maximum speed. In this test, the Bykski AIO performed slightly better with an average temperature of 52.5 degrees. Now, during the entire 1-hour run with standard fan curve, the Bykski AIO's pump ran at a minimum of 1,658 RPM, maximum of 2,327 with an average of 2,052 RPM. This should give us an idea how the pump responds to the standard fan curve. Now, at maximum pump speed settings, the Bykski AIO's pump maintained its rated maximum speed of 2,300 RPM during the entire run, which is a good sign. Now, here's the CPU voltage of the AMD Ryzen 5 2600X with PBO and CPB enabled during the entire 1-hour run. And now, here are the frequencies during the entire 1-hour run. As you can see, the processor maintained its boost speed of around 4.1 GHz to 4.2 GHz, which gives us an idea that the processor is indeed running on high load during our testing. Next, I did another run of everything just to give us a more accurate data to compare with. And since I ran out of stock thermal paste from Bykski packaging, I took this as an opportunity to test the performance of the Noctua NTH1 thermal compound. So at 15-minute idle time, the Bykski AIO's average temperature dropped slightly at 40.5 degrees. And in a 1-hour AIDA64 extreme stress test, the result is quite consistent with a slight drop of temperature for the Bykski AIO with an average temperature of 53.5 degrees. Now, during a 15-minute AIDA64 extreme stress test with all the fan including the pump set to max, the Bykski AIO's average temperature interestingly got a bit higher at 52.2 degrees. Now, at this point, we can only see a slight difference between the performance of the stock thermal paste versus the Noctua NTH1, and the data is quite consistent if you look at the result of the ID Cooling Frostflow X as well with the Noctua NTH1. It's either the stock thermal paste of the Bykski AIO is just good or the Noctua NTH1 isn't that great. In my opinion, it could be the former. Next, and as a final test, for a 30-minute Csgo Gaming test which should be our real-world performance benchmark, the Bykski AIO's average temperature is 52.1 degrees, which is pretty decent considering that Csgo is a CPU-intensive game. By the way, I know some of you guys are going to be curious, so I also checked the temperature of the RGB part of the pump and see if it heats up alone. And thankfully it does not, the temperature is just around our ambient temperature. Overall, performance-wise, I wasn't really expecting much from this AIO judging by the packaging, build quality, and the 1500 RPM radiator fans. But it definitely exceeded my expectations. This is one of those instances that you really can't judge the book by its cover. So to conclude, the Bykski AIO proved to be quite decent in both aesthetics and performance departments. The addressable fans, albeit rated at a lower fan speed, looks really dope, complemented well with the equally good looking pump with a nice honeycomb design and a subtle Bykski branding. The pump responded well on both standard fan curves and at max full speed, indicating reliability when it comes to performance. Mounting implementation is good, but I think they need to improve a bit when it comes to build quality, especially with the plastic mounting part of the pump. Overall, I really like this AIO. Certainly an eye candy, and if you're looking for an AIO that is both aesthetically pleasing and can perform well, then this is a good option. And there you have it guys, thank you for watching. Make sure to check the full article link below. Huge thanks to Bykski PH for sending this in. You can get this from the official partner stores link below as well. Thanks to Sir Tom Bermore for giving me a set of ID Cooling case fans as a gift to upgrade my OEM case fans. I really appreciate it, Sir Tom, thank you very much. You can check his channel by the way, link below. Thank you for watching, subscribe if you like this, and see you next time. Have a great day.